So quiz 4 preview, again, we're going to be playing with the calculator and be playing with our formulas, algebra a little bit with these, getting you ready for the quiz. Important thing come quiz day is that you're reading the directions carefully so you actually do everything that you're supposed to do. So we're going to graph here, and again, we can talk about with the calculator, the pattern, whatever. I put a table over here. If you don't want to use the table, you don't have to. Okay. And then we're going to do the vertex, the axis of symmetry, if it's a min or a max, the domain and range. And I put blanks in for all of these to kind of remind you of that so you don't forget anything. So, okay, let's start with the easy stuff. At least I hope it's the easy stuff. What's my vertex going to be in number 1? Okay, negative 1, 2. Because it's the opposite of h and k. And so, if you happen to forget that on the quiz, if you've got your cheat sheet, you can actually see that. I don't even care if you put on here that your vertex is hk. Okay, that doesn't bother me. Now, I'm not going to have you put in like full-blown examples on here, but little things like that, something to trigger you a little bit, maybe not be a bad idea. And if you need another cheat sheet, I've got them over in the folders. So we've got our vertex, negative 1, 2. At this point, when I go to graph, we've talked about how we have two options. I can either use my pattern with my a value, thank you. Don't know who that is. All right. And then go from there, or I can use my chart. Now, when we talked about the pattern before, the pattern would just be, we're opening up, it's positive. So I'd go up 1 and over 1 each way, put a dot. I'd go up 3 over 1 each way and put a dot. And that'd make my parabola. If I don't think of that, okay, if that's something I really don't want to deal with, here's my other option. I can go ahead, I can plug it into my calculator. And again, the windows may be weird after some of the stuff we did yesterday. So if your window is weird, let me talk about that for a second. So let's say you hit yours like, whoa, I can't even see it. Okay. My window should look like this when I'm starting. Negative 10 to 10 for both my X and my Y mins and maxes. So I just hit the window button. That's a typical screen we're looking at. So I hit graph, okay, I see my parabola. Yeah, it kind of looks like what I got here. So I go second graph to my chart, and I get my vertex in the middle. Why the vertex in the middle? I see symmetry. I see the same thing on the top and bottom. Now, if you want to write those values into a chart, and I'll do this on one of them, you could put your vertex in the middle, and then again, take a couple of values above and below and just copy them from the chart on my calculator. And you'll notice I actually have all of those points plotted already using my pattern, but they both got me to the same place. And I can make my parabola. Okay? That should make it easier for me to get all the rest of my information at this point. My axis of symmetry is always just x equals, I got to put that part in, I can't just put the number, but this is always going to match up with my vertex's x value. Min or a max. This is another one should be, once I see a picture, should be an easy question. Minimum, because my vertex is at the bottom. Okay, if it opens up, I have a min. If it opens down, I have a max. And then hopefully the easiest question on the entire quiz, because it's the same every time. My domain goes forever to the left, forever to the right, no matter what, even if it opens up or down. But my range, not quite the same, doesn't go down forever, it only goes down to right here at 2. Oh. Matches up with this value, and it always will. And then it goes up forever. I mean, you're looking there at a 5-point question, but there's really not a lot of parts that should cause us too much trouble. So we kind of keep looking. We're like, okay, we're getting warmed up a little here. Ooh, Harty's getting sneaky on number 2. What's the vertex on number 2?
0, 3.
Okay, now let's look at this for a second. When we think about vertex form, the number in parentheses is always going to be my x value, but there are no parentheses here. So I could actually rewrite this if I wanted to. If it was in vertex form, it would look like this. So if you only see a number and there's no parentheses, that first value will be 0. And again, we always keep whatever's on the outside. So some of the answers I heard made sense. I'd heard 3, 0. I'd heard 0, -3. I get all those. But again, it's kind of getting a grip on our vertex form. So 0, 3. Put it on. So then I look, and I'm like, okay, my a value, once I come down a little, is -2. Now if I'm going to use the pattern, if I'm going pattern, I go down to an over 1 each way. Then, and this is the part where people do the pattern, like, wait a minute, what? The pattern is normally, you know, up 1, up 3, up 5, and we're doing over 1 each time. But now, since that 2 is there, I went down 2, over 1 with my first one. Now I would go down 1, 2, 3, 4, 5, 6 over 1 with each one. And again, the pattern is an option, not a necessity. If that doesn't click for you, you know what I'm going to say next. Use the calculator. Okay, we've always got a backup plan for things. So I type in my equation, my -2x squared plus 3. I like looking at the graph to make sure things are looking good. Yep, that looks good. And then again, I'd get my vertex in the middle, which means I need the 0, 3. Because why? I see symmetry. And I would plot my -1, 1, and 1, 1. And my -2, -5, and +2, -5. I get the same numbers. And again, if you want to fill in the chart, you can, but it's not completely necessary. And then I just basically fill in the rest of my info. Axis of symmetry, x equals 0, because that's what my vertex says. My graph opens down, so it's a max, absolutely. My domain always goes forever out to the left and right because it keeps getting wider and larger as you go. Now range, I gotta be careful this time. Okay. Does my graph go down forever? Yes. So I start with -infinity because we always go bottom to top with range. But does it go up forever? No. It goes up to here. It goes up to 3. So, once I get that set, I'm set on this one. So I just got to watch for that a bit. Yes, sir?
Would you have to put in vertex form on the calculator, or could you just type it in the 2x?
You absolutely can just type it that way.
All right.
Yep, that'd probably be the easier way to go. But you'd get the same thing typing either one in. Good question. Yeah, I can always type in exactly in the form that I see it. So then we get away from vertex form. And we get ready to start chatting about our standard form. Now, when we're looking for the x value, because we got to start with our vertex, remember, I got my little formula for this, and there's no real way to avoid it. I'm going to do this -b over 2a. So when I'm doing that, of course, I need to know what my a and b values are, and c could even come in handy. We'll talk about that in a second. So to get the x value of my vertex, I do the opposite of b. The opposite of 6 is -6. over 2a, or 2 times negative 2. Now, again, I got to be careful, especially if I go to a calculator on this. I want to clean this up first. So I'm like 6 divided by 4. I don't even think that's going to go in nice. Yuck. Let's see. Negative 6 divided by negative 4. Ew, 1.5? Really? Did I do something wrong? No, you didn't. That can happen. Okay, so my vertex is 1.5, which means my axis of symmetry is x equals 1.5. You're like, okay, so how do I get y now? I'm going to remind you of our little secret we talked about yesterday. I could plug this x value in for every place in here, and I'll actually do that here for a second. Just again, we like options. So I could go about doing it this way and get my y value out, which is 6.5. But here's your other option. If you're really sure you were careful on your x value, and you type it into your calculator, because we're going to look at the chart sometime anyway, because we're doing it to help me with some of the graphing. And you look at your chart. Now, you're like, wait a minute, but 1.5 isn't here. Oh yeah, that's not going to work every time. I can only cheat with the chart if this isn't a decimal. So that's not going to quite work as well for me. Because you're like, yeah, because now, if I can't find 1.5, how am I supposed to graph this that way? Well, once I get that first point plotted, remember, we have some options. One of the options we talked about was using the Y-intercept. Now, could I use some points on here? Sure. My Y-intercept is always 0 and my C value. Okay? Or I can just go to where 0 is here. See, it also says y is 2. So I go to 0, 2. I put a point. And this is where we talked about the axis of symmetry. When we put in that little dotted line, it was like, oh yeah, that's where the reflection is. So I always looked at my intercept versus my axis, and I'd say, okay, it's 1.5 to get over here. If I go another 1.5 and put a dot, that's my third point. Now again, if that's something that freezes you when you're doing the quiz tomorrow, you can just use points in the chart. I'm not going to yell, I'm not going to scream, I'm not going to tell you it's wrong. And I can get my graph. So it just goes to show you, it's not like it's one way or that's it. Dot my vertex at the top, so it's a max. Okay. It's just playing with them enough to feel comfortable. Even with this new method, domain still isn't changing. Still going forever out to the left and right. But again, the range is the one I have to do a little thought on. And again, it's always bottom to top. Does it go down forever? It certainly does. Does it go up forever? Nope. Well, how high does it go? It goes up to 6.5. And I'm set. Okay. Questions so far? So we got one more of these to look at too, and we'll just look at our options and see how this works out. Not yet. Okay, let me scooch this just a little. All right, again, I would make a quick note of what my A, B, and C is so I can start getting some information situated for myself. Now, like, okay, X value. There's my formula. Opposite of B, opposite of negative 8 is 8 over 2 times A. 2 times 1 is 2. So my X value is 4. Now this time, we're going to have a little more flexibility. Because now that I know my X value of my vertex is 4, one option I have, x squared minus 8x plus 5 is to go to my chart, find my 4, and get it in the middle. Because look, I see symmetry. Okay, I could still plug it in somewhere if I wanted to double check. But to me, that looks like the center to me. 4, -11. Gives me my axis of symmetry. Bless you. At x equals 4. And then I'd just use the calculator. I mean, I see the symmetry right there. Might as well use it. So then we're going up 3 and over 1. Up 3 and over 1. And get it drawn in. So you start to see all the patterns that develop with this. And once you start nailing those, it gets to be a lot easier to work with. It's a min because my vertex is at the bottom. My Y-intercept, just remember, that's occurring when x equals 0. So I can either look it up on my chart, 0, 5, or I can just take it from my C value. Either one works. So all of this stuff intermixes to make life a little bit easier on you. Now this time, does my graph go down forever? No. It's got a point where it stops at -11, just like it was in the vertex. But it does go up forever. And if I haven't mentioned before, it might come as a shock to you, probably not, as we start to get ready to flip to the back here, that your quiz tomorrow, as we flip over, miraculously will also be 13 questions. So as I've said before, you're basically, I'm walking through the test with you, I'm just going to switch some numbers around. So I get to the back, and it says, name the transformations for the parent graph. Remember, transformation is our fancy math way of saying shifts. So when we're looking at these, we're like, okay, reminder, my numbers in the parentheses are my left and right shifts, and they're the opposite of what I would think. Minus is right, plus is left. So we're like, okay, so right 4, got that part, okay. My number on the outside when I'm in vertex form is always my up or down. And again, those go with what I would think. Up is positive, down is negative. So I'm like, okay, that's up 1. Gotcha. Well, wait a minute. There's 3 blanks here. And those are the only 2 shifts. Now again, it doesn't have to just be a shift. A transformation also can be a stretch or flip. And you're like, wait a minute, stretch or flip? Stretch meaning if it's above 1, it can expand or contract, but we can use a general word stretch for this. So on this one, there's a stretch of 3. It's not just your typical parent graph. It's actually going to be a little skinnier. But when we do those same ones on number 6, ooh, now this is the tricky part. What's the -6 mean? Nice. Down 6. It's not in the parentheses. But this time, nope. When we have a negative, when we have a positive slope, it opens, well, a positive A value, it opens up. A means we're opening down, which means we're going to flip it. This went by that negative from opening up to making it open down, and that's where we get this flip that we call it. Negatives flip.
So is it flip 1 or is it flip 1?
You could call it either. because when we say flip, we know it means negative to flip it, but if you put the negative in there, it's not going to hurt anything. So that's how we, again, work with our transformations. But I got to have an idea of what each of those values are doing for me, or what they mean. And then we get to what we talked about for the last couple of days this week. So here come the applications. Ball's dropped from the top of a building. The distance in meters above the ground of the ball after t seconds can be modeled by the equation. I give you the equation. Reminders. That value on the end is my starting point. Okay, if it says the ground at 0, if I give you a value, it's going to be that value. Find the y-intercept of the function. Okay, there's a couple of ways I can do that. We talked a little bit about those yesterday, but seeing the picture can actually help me some on this, so we'll do that. And then maybe we can figure out a pattern here. So I type it in, and I go to hit graph. Uh-oh, I can't see what's going on up here. But do I need to? Well, the y-intercept happens when x equals 0. So if I do second graph and just look when x is 0, oh, y is 45. So my y-intercept is 0, 45. But wait a minute, I've seen that number somewhere already. Oh, yeah, it's my starting point. That's true every time. Whenever you're doing one of these problems, if you're asked where the y-intercept is, it's this number on the end. So if it was negative 16t squared plus 142, 142 is your y-intercept. It's my starting point. Now to find the x-intercept, okay, or the 0, that's when y equals 0, I can still use my graph for this. Now it's not I can't use the chart. Chart's not going to help me very much. But if I look at my graph, we talked yesterday about how we can find this point, this 0. So we'll go through the steps again here. It's second trace. I'll even put it on here. I'm looking for the 0, so I want number 2. And we talked about my job being trapping it. Because here's basically what I'm doing with this. Okay, there's my cursor guy. My job with this graph, okay, here's my curve, here's my axes. I'm trying to figure out what this point is. What I'm going to tell the calculator is I'm going to pick a point above the x-axis. So like where it's blinking right now, that's fine. I'm going to hit enter. Oops. Oh dear, there went my calculator. Okay. Now when it says right bound, I want to pick a point below it so I can trap it in. So I want a negative y value. I choose a positive y value above. Now I see down here with y it's negative, and I'm going to hit enter twice. And then the calculator figures out for me what the x-intercept is, and the significance of that. The ball hits the ground at this time. X values are always about time. Y values are always about how high something is, or how far it is, or how much it costs.
Isn't there a non-calculated method for it?
For finding the 0, your only other option would be if you use the quadratic formula.
Oh.
So most people are like, ew, I don't know if I really want to go through all that to find that point. But again, I'll have a couple of notes up about calculator presses if you're trying to do those tomorrow, because I don't want to leave you hanging on that. So hopefully that can put you a little bit at ease on that. We're going to see another one of these in a little bit. For each function, find the y-intercept. Now, could I type it in my calculator? Sure. If we're in standard form, we just got done saying this, that's it. That's your y-intercept. It's the number on the end. That doesn't work on vertex form. I'm just giving you a forewarning. If you're in vertex form, here's your options. I can either manually plug in 0 for x, and I can do that on my calculator if I wanted to. That would work out just fine. I could literally type it in like that, get an answer out, which would be, I'm going to do it calculating myself here. Take me a little longer. I can calculate it myself, or again, and this sounds like a broken record, but it seems to be true on all these things, I could. Technology is great when we know how to use it. I could put it on my calculator and look at the chart and check it out. X is 0, oh, Y is 7. Okay, I didn't have to do that part. I can just look it up here. But it's remembering and figuring out the differences. Vertex form, I got to plug it in or I got to use the chart. With the other one, you're like, could I use the chart on this one? I could. I can just plug that in and use the chart and I'd get the same answer. If you just say Y-intercept equals 7, I can live with that for now. Now, here comes the open-ended question of the quiz. Guaranteed something like this is coming tomorrow. If I give you a vertex for a given parabola, is there only one equation you can create, y or y not? Okay, let's make up something. I give you a vertex, I don't know, say 2, 4. Can I only make one equation using vertex form? Well, let's see. I do x minus h, and again, you have this on your cheat sheet, squared plus 4. Okay, that would be one example. Is there a way I could change that to make another equation? Yeah. I can change the a value. I could say, okay, I'm going to stick a 3 in front of this now. Everything else stays the same. Same vertex. They both have a vertex at 2, 4. But this one's going to be skinny. This one's not going to be as skinny. That's my parent graph. So, is there only one? No. Why or why not? Okay, you could put, oops, if I know how to write. I don't care if you did your answer this way or even if you said, I can change the a value. Because the a value makes it skinnier or fatter, but it doesn't move the vertex. Okay. Thinking that type of way is something I'm going to be looking for to see if we can find a way to do that. So as I keep looking, okay, here comes another one of our applications. We have an equation that gives the height of the ball, starting at 5, in feet above the ground at t seconds after the ball is thrown upward. How many seconds after the ball is thrown will it reach its maximum height? Okay, the height is going to be the y value of my maximum. The seconds is going to be my x. I need to find 1 point. I need to find the max. So, let's do it. So I'm going to clear this out. Now, it is possible to do this one without using the graphing function. I could use my little formula, my negative b over 2a, get my x, and then plug it back in. And if that's something you're more comfortable with, I'd absolutely tell you to go for it. Okay, so I hit graph. Oh, I can't see the top number here. Crap, now how's that work again? Okay, remember, we talked about if I can't see the top, I'm going to look at the chart. And I want to find out how high do these numbers go? 21 and then it starts going negative? Okay. So since my biggest y value is 21, maybe in the window I make it, I don't know, 30, let's say. I want to make it bigger than the biggest y value. So let's see if that helps. Okay, now I can see it. Makes me happy. Once I can see it, we'll make a little note here again. We're going to do second. We're going to do trace. You're like, dang, we do second trace a lot. Yes, we do. And we want the maximum. We want number 4. So, here's my little cursor dude. Again, we try to get up as close to the vertex as we can. And once we're there, here we go again. We're sort of doing the same thing that we did before. So here we are. I'm trying to get this guy. So here's my job. I'm going to click left 1, 2, 3 times because I'm trapping this point in. So when I do that and hit enter, that gets locked in. 1, 2, 3 to get back to the top. 4, 5, 6 to make my other border. Again, we're trapping it in like cops trapping a criminal in a house. And then we just hit enter twice with my guess. And we find out if we round, after 1 second, if you put 0.999, I'm not going to mark it wrong, it's 21 feet high. Okay? It's all about trapping the value in and finding that answer. But again, I will have help up for you on button presses with that while you're doing this. Okay, and then finally, one more help with the cheat sheet. I'm going to use my condensed version here. Calculate the focus in Directrix. Okay. What's my A value here on number 12? 1, because there's no value in front. And then here, I'm going to write down my vertex because that could come in handy. -4, 0. So I'm like, okay, we're not centered at the origin because when I'm looking at my cheat sheet, if it's 0, 0 for my vertex, I'm going to use this side. If it's anything else, I'm going to use this one. So I look, okay, it's not that. So how does this work? Well, it says my focus is going to be this HK plus 1 over 4A. Okay, so let's see here. Here's my H and K. So it's H, -4. Now this part is K plus 1 over 4A. I just plug it into the formula that I got on my sheet. And I look at that, I'm like, well, 4 times 1 is 4. So that's 1/4. 0 plus 1/4 is 1/4. And if you did it in the calculator and got 0.25, that's fine. Not a big deal. But again, I'm using the cheat sheet to help me. So this one says K minus 1 over 4A. K minus 1 over 4A. It's straight middle school substitution. Don't make it worse than it is. 1 over 4. 0 minus 1/4 is -1/4. I'm done. Not a bad thing. I've just got to write down my values. And I've got all this on the cheat sheet, what all the different things are. So then my last thing, they're like, thank God. It's the longest 13 questions of my life. I don't have any shifts this time. My vertex is at 0, 0. So this time, I'm going to be using the side that says with the vertex at the origin. So I look. My focus says 0, 1 over 4A. 1 over 4 times -2. And again, do this in your head. If you're going to go to the calculator, just do this bottom part. Don't type the whole thing in because you're going to get a weird answer. 1 over -8 or -1/8. And that's it. Directrix, every bit as easy. It's -1 over 4 times -2. The only thing that's going to change is the sign. Instead of -1/8, it's positive. Okay? This stuff, honestly, if you've practiced it all, and we talk about that, but that's kind of your call, This one? Over here? Yes. Yep, that's a -8. So again, you've got some places to still practice a little bit. So just a couple of quick tips, and then I kind of can just let you on your own to see what you think is best for you, kind of finding your why, like we talked about before. What I would do to get a little bit of additional practice to make sure I just don't look at this and come in tomorrow and I'm like, yeah, I got this, and then you look, you're like, oh crap, Harty's not talking. Reminders. When we did our focus and Directrix stuff earlier in the week, we talked about in the back of your packet, there was this thing called a graphing review, which is part of the homework check. This will let you practice what we just did. It's a good way to get some extra practice. Like I said, it's part of the homework check anyway. It gets you some more. If you need some more with the story problems, maybe go back through a couple of those that we did yesterday. Just some options for you, okay? But when you come in tomorrow, quiz that looks just like that, homework check, and then you're good and ready to go till after we get off of your little break.